Hello friends, I welcome to you in your YouTube channel Physics and You. Today I am here to discuss a new animated video related to Einstein's photoelectric equation. Let's start the video. So first of all, what is the photoelectric effect? Photoelectric effect is a phenomenon of the ejection of electron from a metal surface when a light of a threshold frequency incident on it. What did it mean? Let's take an example. Suppose you have a metal surface. That metal surface consists of atoms. Atoms contain valence electron, outermost free electrons. So what happens when a light of a threshold frequency energy E equals to h mu, or light having a threshold frequency mu naught incident on a metal surface, it knocks the outermost electrons and eject from the metal surface. That phenomenon is called as a photoelectric effect. In 1887, German physicist Hirst firstly observed this phenomenon when he has performed an experiment of spark gap generator. And later on, Philips Lenard has investigated this effect when he has exposed a UV light on the zinc plate, and he has observed a few facts, or he has concluded the few things. What are that observations? Observations are like that: when a UV light incident on a zinc plate, that zinc plate become uncharged initially if negatively charged. First point. Second point is zinc plate become positively charged if initially it is uncharged. Third point, zinc plate become more positively charged if initially positively charged. So these are the few observations they have observed, and they have concluded it means negatively charged particles are emitted by the zinc plate when UV light is exposed on that plate. So that is a strong evidence behind the existence of photoelectric effect. On that basis, Einstein has used the Planck's theory to explain this photoelectric effect, in which the radiation is considered in the form of a discrete amount of energy. Okay? That means indirect way we can say radiation is traveling in the form of a discrete energy or discrete photon. That energy of a photon is given as E equals to h mu, where E is energy, h is Planck constant, mu is frequency. And in 1921, Einstein awarded for the Nobel Prize for his contribution toward the explanation of the photoelectric effect. So what he has concluded, what he has made? So he has made, when we have a sufficient amount of energy to eject a particle, that is called a work function. If we have a sufficient amount of energy to eject that particle from a metal surface, he has given a wide range of the equation in a simplest form. How? Here W is a work function, h is a Planck constant, mu naught is a threshold frequency, that is minimum energy. So by the means of a conservation of energy, how he has interlinked? He has interlinked all the process, entire concept in a one statement. That means to energy of an incident photon is equals to sum of work function plus minimum kinetic energy. So what it mean? Again come back to the animation. You have a metal surface, light of threshold energy or frequency E equals to h mu, okay, incident on it. Assume that energy having a frequency greater than the threshold frequency, then and only then it will eject the particle from a metal surface. So means it having a minimum work function W plus kinetic energy of the ejected particle Ke. So it is given as incident energy h mu equals to h mu naught work function plus kinetic energy. This equation is called as a Einstein photoelectric equation. Hope you like the video. If you like the video, hit on the subscribe button. Thank you very much.